In this scene in Django Unchained by Quentin Tarantino, Django is on top of a staircase and shoots a pistol at another character, Miss Laura. The force of the pistol then sends Miss Laura flying off at a different angle into another room.
All the physics are correct in the scene until Django shoots Miss Laura. The bullet is shot from Django's pistol and hits Miss Laura in the chest. She then flies off at an angle into the other room. Instead of flying off into the other room, Miss Laura would have crumpled to the floor since the bullet from the pistol does not exert enough force on Miss Laura to cause her to fly back. Also, the angle at which she is shot would not cause her to fly at a different angle. It would instead cause her to fall in the same path as the bullet.
Since the bullet is going straight into Miss Laura, the angle would be 180 degrees, or straight, not at an angle into the other room. We estimated that the angle she flew back would be about 60 degrees to the left from the 180-degree angle. This is not possible because if she were to move, she would continue in the path of the bullet and not go off to the side.
To find out if Miss Laura would indeed fly backwards, we are using inelastic collisions. To calculate for the velocity that Miss Laura will fall, we need to solve for momentum. We estimated that Laura Caillouet is about 58.967 kilograms. Miss Laura is standing still, going 0 meters per second. The velocity of the .44 caliber bullet is 252.984 meters per second, and it is shot from a Remington 1858 .44 caliber gun, and the mass is 0.0136 kilograms. After calculating the velocity of Miss Laura after the bullet had hit her, we found that she is traveling 0.58 meters per second.
To find out if she would actually be thrown back, we solved for force using the formula F equals ma. But before we could solve for that formula, we needed to find her acceleration, A equals v2 minus v1 divided by time. Since she wasn't moving when she was shot, and then moved 0.58 meters per second, her velocity 2 minus v1 equals 0.58 meters per second. To find the time, we estimated that the time the bullet accelerated her was about 0.1 seconds. We then solved for the formula and found that she was accelerating at 0.058 meters per second squared. Now that we solved for acceleration, we can solve for the force. Since we have the mass 59.103 kilograms and the acceleration 0.058 meters per second squared, we can find the force, which is 3.42 newtons. Because the force is so small, Miss Laura will not fly backwards at all. The only reason she actually falls
is because she is killed by the shot, not because she is propelled backward. This scene in the movie is not using good physics for two reasons. First, the angle that Miss Laura flew back is not possible to achieve from the angle that the bullet was fired. Second, the force of the bullet is not great enough to launch Miss Laura in the air. Instead, she will crumble to the floor.